Hi everyone, my name is Ravi Prakash and this is the 14th class of geometry, right? Geometry 14. In this we'll discuss about uh, 30, 60, 90 triangles, 30, 60, 90 triangles, its applications, 45, 45 and 90 triangles, its application, then equilateral triangle and all, right? So we'll discuss it, right? Okay. See, 30, 60, 90 triangle, 30, 60, 90 triangle. Now, what is this 30, 60, 90 triangle, right? In name you can see it contains a 90 degree. That means it is for right angle triangle. It is for right angle triangle, right? Now, similarly, 45, 45, 40, 45, 45, 90 triangle, right? Again, it's for right angle. There's two kinds of right angle triangle, right? Two kinds of right angle triangle. Most frequently used is 90. Let's say this is 30. This has become 60. In 45, 45, 90, let's say this is 90, this is 45, this becomes 45, right? So this is quite easy, 45, 45, 90 triangle, because it is right angled isosceles triangle. In any triangle, if two angles are equal, their opposite sides are also equal. So this is 45, 45, so these two sides are also equal, right? So if 45 is opposite, I assume it to be 1, this also becomes 1. So this becomes root 2. What is the ratio? Ratio is 1 is to 1 is to root 2. 1 is to 1 is to root 2, right? Ratio is 1 is to 1 is to root 2. By Pythagoras theorem, it becomes root 2, right? Now in 30, 60, 90, 90 triangle, we need to derive it, right? So let's assume 30 opposite to be 1. Let's assume 30 opposite to be 1, right? Now applying tan 60 here, applying tan 60 here. What is tan 60? Tan 60 is what? Perpendicular by base. So what is tan 60? It is root 3. Perpendicular is what? Whichever side angle you are taking, opposite is perpendicular. This is P. So P, and what is the base? This left, this is base, right? This one, because this is hypotenuse. So whichever angle you are taking, its opposite is perpendicular. One is for sure hypotenuse. The left out one is the base, right? Always. So you can watch this basics of trigonometry video by me. I have recorded it, right? So please watch this video. So tan 60 is root 3 is P upon B is 1. B I assume to be 1, right? Therefore, P is now root 3. So if P is root 3, then what I can do, okay, P becomes root 3. Then H is what? Root under 1 is square plus root 3 is square, right? That means H becomes root 4, that is 2. Right, so H becomes 2. So if 30 opposite I assume to be it to be 1, 60 opposite is root 3 and 90 opposite is 2. So what's the ratio? It becomes 1 is to root 3 is to 2. 1 is to root 3 is to 2. So 30, 60, 90, the ratio is 1 is to root 3 is to 2. 30 opposite is 1, 60 opposite is root 3, 90 opposite is 2. 45, 45, 90, what is the ratio? 1 is to 1 is to root 2. Okay. Now we'll see its application, right? We'll see its application. Okay. Just remember it. 30, 60, 90. Ratio is 1 is to root 3 is to 2. Okay. And 45, 90. Ratio is 1 is to 1 is to root 2. 30, 60, 90, 45, 90. Okay. Now see here, in right angle, so don't take right angle, I can take any angle now. We'll see its application. Okay. See, in any triangle, let's say this is a triangle, and this triangle is ABC, and this is the altitude. This is 90 degree. Okay, this is AD, and this length is, let's say, 100. Okay, this is 60 degree. Sorry, make it 30 degree. This is 30 degree, and this is 45 degree, right? Now see, it's a similar application you can see in height and distance chapter in trigonometry, right? Let's say there's a building AD. There's a building AD here, right? There's a building AD. On one side, now this is the earth. This is a building, this is one building of height 100 meter. If I see from one side, the angle, if I see it from point A, right, or point B, I can write point B, the angle of elevation is 30 degree. This is the angle of elevation, right? Angle of elevation means seeing upward. Okay. And if I see it from point C, the angle of elevation becomes 45 degree. This is the angle of elevation, right? Seeing up. Notice angle of depression. So angle of elevation or angle of depression, it is always found by the horizontal line. Angle of elevation or depression. Angle of depression, right? Always found by the horizontal line, right? Suppose if I ask you, okay, from this point, angle of depression to point B, this is point B, right? This is point B. So if I ask you the angle of depression from point A, angle of depression to point B is 30 degree. So point A, angle of depression. So don't mark this angle as 30 degree, right? No. Angle is always with horizontal line. So draw a horizontal line here, right? And then this angle is 30 degree. So angle of depression from point A to B, this is 30 degree, not this one. Not this one, right? So this is a similar application to height and distance chapter. Fine. Okay, this AD is 100 now. So see here, in this triangle, now 30 opposite is 100. If 30 opposite is 100, then 90, so you see this ratio here. This 30, this is 90. So this automatically becomes 60. This automatically becomes 60. This is for 90, it is 45. So this becomes 45. Now see, this triangle, this is a 30, 60, 90 triangle, right? So in 30, 60, 90 triangle, what is the ratio? Ratio is 1 is to root 3 is to 2. If 30 opposite is 1, then 90 opposite is 2, double. So if 30 opposite is 100, so 90 opposite is what? 200, right? So I draw a figure with ABC triangle, AD as the altitude and AD is given as 100. So with this information, I can find each and every length in this figure. That's what I'm showing you, right? So 30 opposite is 100, 90 opposite is 200, because what is the ratio? 1 is to 2. Now 30 opposite is 1, 60 opposite is root 3. So 30 opposite is 100. What is 60 opposite? 100 root 3. What is the ratio? 1 is to root 3. So 60 opposite is what? 100 root 3. Okay, fine. In this case here, 45 opposite is 1. So if 45 opposite is 1, so it is also 1, it is root 2. Here 45 opposite is 100. This also becomes 100. And this becomes 1 is to 1 is to root 2. So 100, 100 and 100 root 2. 100 root 2, right? So we got the answer. With this information, I have calculated every other figure in this, every other length in this figure. This is the application of 30, 60, 90 triangle and 45, 45, 90 triangle. Okay. Now see, we'll keep on using it now. Right now, I'll use it in case of equilateral triangle, right? Equilateral triangle. We'll discuss all the concepts about equilateral triangle, right? And we'll apply 30, 60, 90 concept also. See, equilateral triangle is what? In equilateral triangle, first of all sides are equal. That we know, obviously. All angles are equal. And they're equal to how much? 60 degree. Okay. In center, circumcenter, centroid and orthocenter are same point in equilateral triangle. Are same point in equilateral triangle, right? So all sides are equal, all angles are equal to 60 degree. In center, circumcenter, centroid and orthocenter, all are same point in equilateral triangle. Okay. So see, in this case, I'm drawing equilateral triangle here. See, equilateral triangle ABC, all sides, let's say A and A, all are equal, right? Now, if I drop a perpendicular here, right? Right? Now, this perpendicular, since orthocenter lies on perpendicular. So let's say orthocenter will lie somewhere here, right? Now orthocenter is equal to centroid. That means this AD is median as well, right? Let me write like this. This AD, this whole is A obviously, right? This whole is A. So since orthocenter lies on perpendicular, so this is like orthocenter and orthocenter and centroid at same point. So this is centroid also. That means AD is median also, right? That means AD is altitude. AD is also median, right? So AD is median also. Okay. Now if AD is median here, that means centroid divides median in the ratio of 2:1. That means this is the ratio of 2:1, right? Centroid divides median in the ratio of 2:1. Okay. Now AD is the this point, let's say this point O. This point O is the circumcenter as well as incenter. Circumcenter means keeping this point as center and taking any one vertex as radius. Right? I can draw a circle which will touch triangle from outside, right? Let me draw a better circle. Okay, so which will touch triangle from outside, like this, something like this. So this is the radius, right? And what is in radius? So this in radius is keeping keeping any one side as perpendicular distance. This is in radius. I can draw a circle which will touch triangle from inside, like this, right? This is touching here. This is in circle, right? So you can see here, capital R is here 2, small r here is 1, because it is centroid and centroid divides median in the ratio of 2:1. That means circumradius is to in radius. The ratio is what? It is 2:1 in case of equilateral triangle. Circumradius to in radius, what is the ratio? 2:1 in case of equilateral triangle. Get these points in mind, right? Get these points in mind. You can draw an image in mind, right? Equilateral triangle, all it's a full symmetrical figure, right? Orthocenter, circumcenter, incenter, centroid, all are same point, right? That's why AD is median as well as AD is altitude, as well as AD is the what you call angle bisector, as well as AD is the side bisector. All AD will be all are same in case of AD, right? That means, so if you draw that perpendicular, so all points are concurrent, all are same point only. That means that one will be inside circle, one will be outside circle. Since it is centroid, what is the ratio? 2:1. So circumradius and in radius, what is the ratio? 2:1 in case of equilateral triangle. Okay. Now let me write here. Again, let me make an equilateral triangle here. So you discussed all these points, right? That's all these points will be same now. So ABC, and now if I draw a perpendicular D here, so this D should be the median as well. So it becomes A/2. This is angle bisector as well. So all angles are 60-60. This becomes 30 and 30, right? This is the height of equilateral triangle, right? This is A. Now you see triangle ADC. Triangle ADC is a 30-60-90 triangle, right? 30-60-90 triangle. Here 30 opposite is A/2, right? So what is the ratio? 30-60-90 ratio is 1:√3:2. Okay. So 30 opposite is A/2. So 60 opposite is what? A/√3. What is the ratio? 1:√3. So 30 opposite is A/2. What is 60 opposite? A/2√3. That means height of first point, height of equilateral triangle is A/2√3. This is the first point in case of equilateral triangle. Number it. So first point in case of equilateral triangle, height is A/2√3. Second point, area. What is the area of equilateral triangle? What is the area? Area is half into height into base. Right. What is the area? Half into what is the height? A/2√3. What is the base? This whole is the base, that is A. Right. So half into A. Right. Therefore area becomes √3/4 into A square. Second important point, area is root 3 by 4 a square. First point, height is a by 2 root 3. How it comes? It comes simply by 30, 60, 90 application. So area is root 3 by 4 into a square. Okay. Third point. See, third point is circumradius and inradius, right? So we just discussed right now that this point is circumcenter as well as incenter. This ratio will be what? This ratio will be 2:1. Right? This ratio is what? 2:1. It is 1 is inradius, this 2 is circumradius, capital R. Right? So this obviously, this R plus R is the height. This R plus R is the height of the equilateral triangle. And this height is divided in the ratio of 2:1. That means circumradius is what? It is 2 by 3 of height. Right? That means 2 by 3 into what is height? A by 2 root 3. So will get cancelled. 2, it becomes a by root 3. So another super important point, circumradius is what? Circumradius is a by root 3 in an equilateral triangle. And since inradius is half of it, so what is inradius? A by 2 root 3. So inradius is a by, sorry, right? R is capital R is 2, small r is 1. So inradius is half of circumradius. So what is inradius? A by 2 root 3. You can also get inradius by, what is inradius here? It is 1 by 3 of height. The ratio is 2:1, so inradius is what? 1 by 3 of height, right? You'll get inradius as a by 2 root 3. So third and fourth. So first, second, third and fourth, right? 4 super important points in case of equilateral triangle. Should remember it. Capital R a by root 3, small r a by 2 root 3. Height is, area is root 3 by 4 a square, and height is what? A by 2 root 3. This is the height of equilateral triangle. Okay. Fine. Now, let's do a question here. Question. There is an equilateral triangle. There is a equilateral triangle with side 2 units. Right? A circle is circumscribing it. A circle is circumscribing it, and another circle is inscribing it. Correct. Now, to the outer circle, again an equilateral triangle is drawn. Which inscribes the outer circle. Which again an equilateral triangle is drawn, to which outer circle acts as in circle. Okay, so find the area of the bigger equilateral triangle. Right. Just read the question here. The question is again language problem, right? Nothing else. The question says there is an equilateral triangle, right? There is a circle which inscribes it. There is a circle which circumscribes it. Like this, right? And then again there's a equilateral triangle to which outer circle acts as in circle, right? That means this is again an equilateral triangle drawn like this, right? I've drawn best possible diagram, right? Kindly cooperate. So now for this equilateral triangle, this side is given as 2 units. We're finding the side of the outer side. What is the side of the outer triangle, right? It's very easy question. Right, you observe it here. See, in this equilateral triangle, this center is the common, right? This center is the common. Okay. For both this circle, this is the common center, right? So if here the equilateral triangle has side 2, okay, so you can see it. Yeah, if an equilateral triangle has side 2, you can see it for the circumradius, right? For this triangle is circumradius. What is circumradius? Circumradius is r, right? Circumradius is r. What is r? R is a by root 3, right? This is 2. This is given as 2. Circumradius, sorry, not 2. Side is given as 2. So what is circumradius? Circumradius is what? 2 by root 3. For this equilateral triangle, this circumradius, right? This circumradius becomes what? It becomes 2 by root 3. Fine. 2 by root 3. Now, again, for this bigger triangle, this circle acts as in circle. So if this side of the bigger triangle, let's say it is, don't mention a here, right? Don't mention a here. Make some other side here, right? Let's say side is x. So circumradius is a by root 3. General formula. A here is given as 2. A here is given as 2. So circumradius becomes 2 by root 3. Okay. Now, to this bigger circle is the in circle for outer triangle. So if the outer triangle has side x, its in radius should be how much? X by 2 root 3. Right? This in radius of outer circle should be how much? This is the in radius, right? This for this circle it is x by 2 root 3. And this is the circumradius for the inner circle, right? The same radius is given by 2 by root 3. So I can equate it. Therefore, 2 by root 3 is equal to x by 2 root 3. Right? This root 3 cancel. So x becomes 4. That's the answer, right? X becomes 4. Therefore, x becomes 4. So 4 is the answer. What is the area? So area is what? Area is root 3 by 4 a square. So if x is 4, so area becomes root 3 by 4 into side square, that is 4 square. This is the answer. Right, this is the answer. So again, come back to it. What is the question? Question was, there's an equilateral triangle, a circle is inscribing it, as well as circle is circumscribing it. This triangle, right? Now there's again an equilateral triangle drawn, to which the outer circle acts as the in circle, right? So again an equilateral triangle is drawn, this bigger one, to which this outer circle acts as the in circle. It acts as the in circle, right? So if outer circle has if outer triangle has side x, so this is the in circle for it. So what is the in radius? This in radius is what? This in radius is nothing but, this is the in radius for the outer triangle, right? What is the in radius? X by 2 root 3. We have just studied previous slide. So what is in radius? X by 2 root 3, right? And when equating and when seeing from the inner triangle, for inner triangle it acts as, this circle acts as circumradius. So if inner triangle has side 2, what is circumradius? 2 by root 3. So both the circle has got radius same, we can equate it. This root 3 cancels, so x equal to 4. So if x equal to 4, what is the area of bigger triangle? Root 3 by 4 into 4 square. Okay, so it's a good question, very good question, good concept, right? Kindly note it. Okay, so we'll study further in next video. Thank you.